This video covers the following topics. First, we will give a general introduction. Then, we will explain each point in detail. Two-point perspective is a term that refers to a type of linear perspective that uses two vanishing points on the left and right. Two-point perspective allows you to construct scenes dynamically that would not be visible in one-point perspective. Specifically, it lets you view objects from a diagonal angle. In one-point perspective, a cube appears with only one visible face at the vanishing point, while in two-point perspective, two faces of the cube are visible. In one-point perspective, vertical and horizontal lines do not converge, only the lines in the depth direction converge to the vanishing point. In two-point perspective, vertical lines do not converge, but both depth and horizontal lines converge to separate vanishing points. In three-point perspective, all lines, including vertical lines, converge to a vanishing point. However, the diagonal and curved lines of shapes like stars or circles in the front view should be considered separately, as these lines generally do not converge in any perspective method. How is the camera or human head positioned? In one-point perspective, the camera or head faces the object directly and is positioned straight in front of it. In two-point perspective, the camera or head faces the object at an angle, straight diagonally towards it. If the head is not facing straight but tilted up or down, it becomes three-point perspective. To organize the types of two-point perspective, the diagram would look like this. Perspective techniques only provide options, not the correct answer for the selection. It is related to the sense of composition in how you want to present the subject. I will explain what two-point perspective is. Two-point perspective is a term that refers to a type of linear perspective that uses two vanishing points on the left and right. The way two-point perspective is expressed varies greatly depending on the position of the two vanishing points. Of course, understanding this concept requires more than just this simple definition. For example, the upper view uses one-point perspective, while the lower view uses two-point perspective. These represent the same cube viewed from different angles. So, where does the difference between these two lie? Understanding this difference is key to grasping two-point perspective and serves as the main purpose of this video. First, we will identify the differences that can be objectively observed, and finally, we will interpret the reasons behind them. I will explain how many faces of the cube at the center of the picture plane are visible. In one-point perspective, only one face is visible at the center of vision. In two-point perspective, two faces are visible. This is the primary difference between the two. I will explain how many diagonal, vertical, and horizontal lines the cube at the center of the picture plane has. In one-point perspective, there are two horizontal lines, distinct from the horizon line, and two vertical lines. In two-point perspective, there are three vertical lines and four diagonal lines. Simply put, one-point perspective is made up of horizontal and vertical lines, while two-point perspective consists of vertical and diagonal lines. I will explain how the camera or human head is positioned. This is a case viewed from above. In one-point perspective, they are facing the subject straight ahead. In two-point perspective, they are facing the subject at an angle. I will explain what happens when you tilt your head. In both one-point and two-point perspective, the lines extended at perfect 90-degree angles. This straight extension of lines indicates that the neck remains fixed without tilting up or down. So, what happens when you tilt your head up or down? Tilting your head refers to the action of moving your neck up or down. For example, if your neck remains straight, it becomes difficult to look through a camera positioned this way. Therefore, tilting your head becomes necessary. You could also describe this as bending your neck. Of course, you could tilt your entire body as if floating in space to look downward, but we'll consider that an exception. When you tilt your head, one of the resulting views is a case like this, which corresponds to what is known as three-point perspective. However, we will not be covering three-point perspective in this case. Keep in mind that both one-point and two-point perspective represent views where the head is not tilted up or down, but rather looking straight ahead. I will explain the relationship between convergence and perpendicular lines. Earlier, we reviewed the perpendicular lines, horizontal lines, and diagonal lines in both 1-point and 2-point perspective. What do these lines actually represent? First, perpendicular lines and horizontal lines are essentially lines that do not converge to a vanishing point. However, just because a line is diagonal, it does not necessarily mean it will converge to a vanishing point. For example, as seen in the diagram on the right, the front of the octagon is filled with diagonal lines, but these diagonals, like the vertical and horizontal lines, do not converge to any point, they extend infinitely. In 2-point perspective, vertical and horizontal lines are generally lines that do not converge to a vanishing point. However, it is important to reaffirm that there are lines that extend vertically or horizontally at a 90-degree angle in 2-point perspective. For example, true horizontal lines generally appear at the same level as the horizon line. However, these true horizontal lines are special lines that converge to a vanishing point. While non-perspective horizontal lines may exist in some cases, they are considered exceptions in 2-point perspective. In 1-point perspective, the vertical and horizontal lines do not converge, only the lines in the depth direction converge to the vanishing point. In 2-point perspective, the vertical lines do not converge, but the lines in the depth direction and horizontal direction converge to different vanishing points. In 3-point perspective, all lines, including vertical lines, converge to vanishing points. However, the diagonal lines and curves of shapes like stars or circles seen from the front need to be considered separately. The converging diagonal lines are shown here. This is the case for 1-point perspective, and the key point is that these are lines in the depth direction. In 1-point perspective, convergence due to perspective only occurs in the depth direction. In other words, diagonal lines in the depth direction are the converging lines. In 2-point perspective, and even in 3-point perspective, these diagonal lines generally do not converge to any vanishing point. Since these diagonal lines do not converge, curves obviously do not converge either. For example, drawing a sphere in 2-point perspective is difficult. Of course, it's also difficult in 3-point perspective. While it is possible to incorporate circles, as we learned last time, it results in an awkward sense of depth. Let's imagine a situation where we draw circles or stars and apply perspective to their depth. Initially, these circles or stars are not drawn using perspective. They are made possible through the act of drawing, using intuition. While depth lines can certainly be extended, problems arise when trying to draw curves after extending them. Of course, it's possible to use perspective as a guideline, that is, as a rough reference for size and depth. Additionally, there are often explanations of perspective specifically focused on creating guidelines for drawing circles accurately. However, if you want to represent a strict sphere in a 2-dimensional drawing with precise perspective, using 3D software is preferable. For example, industrial products often require such software, and even in analog methods, geometric knowledge would be necessary. In analog drawing, the skill to construct a sphere from a cube by your own effort, using drawing ability, is essential. For beginners, it's generally best to focus on being able to construct a cube from scratch using 1 to 3-point perspective. In some cases, this alone may be a sufficient goal. This is because, with solid drawing skills, you can construct a sphere from the sense of size and depth of the cube, and then build a face from that sphere. It's not always practical to strictly draw everything you want with perspective. The reason perspective is crucial in architecture is likely because there are few curves involved. In any case, architecture uses specialized software, making it a slightly different case from drawing in general. I will explain the types of 2-point perspective. How many types of 2-point perspective are there? The answer is many. The position of the left and right vanishing points, as well as the height of the viewer's eyes, can result in many variations of 2-point perspective. For example, 2-point perspective at 45 degrees to the left and right is different from 2-point perspective with 30 degrees to the left and 60 degrees to the right. Additionally, even with the same 45-degree angle, changing the eye level from 50 centimeters to 60 centimeters will create different types of perspective. However, although there are infinitely many variations, it is possible to categorize them into a few types. For example, based on the requirement to fit within a natural cone of vision, we can divide two-point perspective into two types: natural two-point perspective and unnatural two-point perspective. Additionally, we learned previously that a natural two-point perspective, which is less prone to distortion, has a cone of vision within 60 degrees. The vanishing points are typically located outside the picture plane, and we can distinguish between different types of two-point perspective based on whether the vanishing points are positioned at the edges of the 90-degree cone of vision or at other angles. When summarized, the diagram looks like this. For information on the cone of vision, please refer to the previous video. The most common type of two-point perspective is the 45-degree vanishing point method, known as two-point parallel perspective. This corresponds to what Robbie Lee refers to as the perfect vertex. It is widely used, likely because it is easier to construct. Perfect vertex is a term that refers to a point located directly below the center of vision where a 90-degree corner is rendered as an actual 90-degree angle in two-point perspective. When the two vanishing points are symmetrically positioned, both the perfect vertex and the vanishing points are equidistant from the center of vision. Extend lines from the station point to the left and right vanishing points, imagining these 3 points forming a right triangle. A right triangle is defined as a triangle where one of the 3 interior angles is 90 degrees. The reason it can be called 45 degrees is that the diagonal vanishing points are each located at a 45-degree angle from the station point. This concept may seem a bit tricky, but essentially, it refers to the fact that the lines extending toward the vanishing points form a 45-degree angle. Note that being 45 degrees does not necessarily mean that the cone of vision within the picture plane is limited to 45 degrees. For instance, in the diagram on the right, the cone of vision is approximately 38 degrees. The key point here is not what cone of vision the picture plane fits into, but rather at what angle the vanishing points are located relative to the SP. Additionally, there are both symmetrical and asymmetrical cases. For example, a configuration with 30 degrees to the left and 60 degrees to the right represents an asymmetrical, non-equidistant setup, yet still forms a right triangle. The key point here is that such cases can still be constructed relatively easily, even analogically, with a right angle ruler. The appearance of each square differs as shown here. It ultimately comes down to the creator's skill to choose which presentation or visual impact they wish to achieve. The indicators of distorted or undistorted are not clearly defined in this context. It may be more of a matter of sense or intuition. For example, most photographs taken by photographers are not distorted, yet there are beautiful and unattractive photographs. In a way, this relates to the issue of composition. The choice of composition depends on the purpose. For instance, if the goal is to express the grandeur of a mountain, one might choose a composition that feels like looking up from below. Various such cases can be considered. I will explain the advantages and disadvantages of two-point perspective. First, let's look at the advantages. Point 1. It allows you to depict scenes that cannot be represented with one-point perspective. Specifically, you can view the subject from an angled position. 2. It appears more dynamic compared to one-point perspective. 3. Since the degree of receding lines is more gradual than in one-point perspective, it can result in a convincing outcome even without precise drafting. First, let's look at the disadvantages. Point 1. Drafting is challenging and time-consuming. 2. The frontal emphasis achievable with one-point perspective is lost, making it harder to discern the subject's exact shape. 3. While one-point perspective allows for simple, clear, and impactful drawings, two-point perspective tends to be more complex. The important thing is to ask yourself, as a photographer, how do I want the viewer to perceive the subject before me? When drawing, you are essentially a photographer capturing and framing your imagined world. For instance, how would you choose to present this simple cube? What purpose does your chosen perspective serve, and what effect does it create? Now, imagine applying this thought process to something like a human face. It becomes even clearer. Perspective techniques provide you with options, but they don't dictate the right choice. Next, we'll learn how to construct a cube using two-point perspective. Please subscribe to the channel and give us a thumbs up.